Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video. Hello everyone, in this video I want to talk about how we can evaluate trigonometric functions. So we're going to start off here with number one. Notice we have a right triangle over here on the left side of the screen where we have the measures of the legs. We have 7 and we have 24, and we see our angle measure up here, theta, in the top left hand corner. So we're just going to evaluate the 6 trig ratios for this right triangle. Notice on the right we have sine, cosine, and tangent, and their inverses cosecant, secant, and cotangent. Well, before we do these trig ratios, we have to know what the length of our hypotenuse is. Hopefully you're looking at this triangle and going, hey, that's a Pythagorean triple, so the hypotenuse is 25. If you're wondering where that came from, you could just use a Pythagorean theorem to figure that out. So we have 7 squared plus 24 squared should equal c squared, with 7 being a and 24 being b, right? A squared plus b squared equals c squared. So we know 7 squared is 49, 24 squared is 576, and that is going to give me, when I add those together, 576 and 50 would be 626, so 625. So 625 equals c squared, take the square root, and that's where our 25 comes from. Okay, so once again, Pythagorean triple because we have integer values there, positive integers for our side lengths. Okay, now we have our 3 side measures. We can go ahead and find our trig ratios. So just remember our acronym SOHCAHTOA, and that'll help us figure out sine, cosine, and tangent. And then cosecant, secant, and cotangent are just the inverses of sine, cosine, and tangent. All right, so for sine of theta, we're working with our angle up here, theta. Opposite would be 24, and hypotenuse would be 25. Moving on to cosine, cosine would be adjacent over hypotenuse. So adjacent would be adjacent would be 7, and hypotenuse is 25. And tangent is opposite over adjacent. So opposite would be 24, and adjacent would be 7. So now for our other 3 ratios, cosecant is going to be our inverse of sine. So this would be 25 over 24. Secant is going to be the inverse of cosine. So this is going to be 25 over 7. And lastly, tangent is our inverse of tangent would be our cotangent. So that's going to be 7 over 24. Okay, so that's how we can evaluate our trig ratios for that example. Now let's take, for example, we have sine of theta already given to us. How can we figure out the rest of our ratios? So I've drawn a triangle here on the right side. I've just inserted theta into one of my acute angles. And let's go ahead and fill out the side lengths that we know. Well, if sine is opposite over hypotenuse, then I know this side must be 5 and my hypotenuse must be 6. And so now we got to figure out what our other leg is. So we could do our Pythagorean theorem, a squared plus b squared equals c squared. Let's just say that 5 is a, so this would be 5 squared plus b squared is equal to 6 squared. So we have 25 plus b squared is equal to 36. Let's move our 25 over to the other side. We get b squared is equal to 11. And now let's take the square root of both sides. Now 11, obviously not a perfect square, so this is not a Pythagorean triple. So let's just say b is equal to the square root of 11. So I'm going to add that to my diagram right here, square root of 11. And let's move this information down just a little bit. Right there would be fine. Okay, so now that we have our 3 side lengths, we can go ahead and find our ratios. So now one thing we do need to be careful with is we have a radical now as one of our sides. So if that radical appears in the denominator of one of these ratios, we're going to have to rationalize it because we can't leave a radical in the denominator. All right, now let's move to cosine. Cosine is adjacent over hypotenuse. So this would be the square root of 11 over 6. So no simplifying that we need to do there. Tangent now is opposite over adjacent. So this is going to be 5 over the square root of 11. 5 over the square root of 11. Now this is a case where we can't leave root 11 in the denominator. So let's rationalize it by multiplying by root 11 over root 11. And we'll get 5 root 11 over 11 for tangent of theta. All right, so now we can just do the inverse for cosecant, secant, and cotangent. So once again, cosecant is our inverse for sine. So this would be 6 over 5. Secant is our inverse of cosine. So that would be now 6 over the square root of 11. And we're going to have to rationalize just like we did for tangent. So we're going to get 6 root 11 over 11. And lastly, cotangent is going to be the inverse of tangent. So we could work with 11 over 5 root 11, or we could go back to our original angle that we had right here, and it's going to be square root of 11 over 5 for our cotangent. Okay, so that's how we can evaluate our trigonometric functions.